Hello and welcome. My name is Ulrych, and here at Manta I'm responsible for research and market education. And today I'd like to talk about metadata and especially active metadata and how it actually helps us empower the innovation, how it helps us drive the innovation. So for a long time it was that the bigger company was, the more successful it was. It was easier for it to reach market, reach customers, and so on and so on. However, as the world changes, and nowadays the secret ingredient to the success seems to be the ability to innovate quickly, rather than necessarily being big. And that ability to be fast means fast to react to customer feedback, fast to react to customers' requests, fast to introduce new products and services to the market, fast to react to current situation, and so on and so on. And this ability to be able to actually react fast is typical, especially for smaller companies, those that do not have that much baggage of a long history, right? They do not have complex environment, lots of historical services, and so on. And this presentation is really about how to use metadata, and especially active metadata, to help us keep that flexibility to innovate, even as the small company grows and becomes larger and somewhat slower. And for large organizations, how to actually regain that flexibility back, right? So I actually borrowed this quote from a recent Gartner report, and it actually shows that our data scientists, data engineers, those who are actually responsible for the innovation, spend only 10% of time on the actual innovation. The rest of the time, the 90% of the time, they actually spend preparing data for the advanced analytics. They are looking up missing or erroneous metadata. They are inferring the metadata. They are looking them up. So basically, if you translate it to a one work week, basically our data scientists and engineers spend only half a day doing the actual work that they are supposed to do. The remaining 4.5 days, they are doing something else, some preparation work, right? And that's actually really terrible. So what can we actually do to help them, right? To reduce the 90% time to something smaller? How we can make their life better and organizations more efficient? So this is the agenda for today, really. I'm going to talk first about our data environment. Why do we spend those 90% of time in data preparation? Then talk a bit about metadata and what it is, and really how to activate it. And at the end, we should have some time for the questions. By the way, if you have any questions right away, feel free to put them into the Q&A or comments box in the platform, and we'll address them at the end of the presentation. So again, why is data 90% of time spent on the data preparation and metadata lookups? Well, it's quite simple, because our data environment is complex, and it's getting more complex every day. Basically, 40 years ago, when we started using computers, we were only using these primary systems that you see on the very left. Those were the systems supporting our day-to-day operations. In the 90s, we realized that the data that we have in these systems, we can use to drive our business better, right? And we started introducing analytics. And back in the 90s, it was primarily around data warehouses. And if we fast forward to today, in recent years, the demand to better serve our customers basically required us to perform more analytics. And with that, and with the new data being available, like introduction of internet, social networks, we're also introducing new platforms to actually do these analytics to perform it, right? So we are introducing data lakes, we're introducing data science platforms, machine learning, and all of this. And with that, our environments are becoming even more and more complex with all these interconnections, with all these dependencies. And that's exactly what makes our data scientists and data engineers quite inefficient, because they basically have to spend time going through this complexity, through this complex environment, to actually get the information that they need to do their job, right? And basically, if you look at this picture, what we really need, or what they really need, is some sort of map of that environment. And in case of data environment, that map is metadata. So what is really metadata? Well, over here, you're looking at the data record. So this is probably my record with name, phone number, some sort of customer record. But if you are actually supposed to work with this data, you need more information than just the record itself, right? For example, how do you know what the activation date is? How to interpret it? What was the meaning of it? Well, we need an additional information, like the fact that it's when the service was started. Or how do we actually know what T in the is active column mean? Is it T as terminated or T as true? Without metadata, without additional information, we don't know, right? But there's much more. We may be interested in the information who actually uses this data. Where does it actually come from? How often it is refreshed? Is it source record, or is it somehow cleansed? Does it contain any PI or even PII information? Right? All of this information is something that our data scientists and data engineers need to have, so that they can do their job, so that they can work with the data properly, that they can interpret the data, that they can use it for machine learning models and know what are the limitations of it, right? And this is exactly that large amount of time where how they are actually spending that time. They are looking up this metadata because they don't have it available on hand. Well, so metadata that we provide to our engineers serve as a map of our data environment and our data pipelines. And actually, let's use the paper map, the actual paper map, as an example. You can use the paper map to plan trip from A to B, right? Plan for your trip for your vacation, for example, right? And our data scientists can actually do the same with the metadata, right? They can use it to navigate through that environment. But if you think a bit further, how many of us are still really using a paper map to navigate? Is there not any better way how to do the navigation, right, rather than drive and follow the paper map? Well, there is. Most of us are using GPS navigation, right? And you can think of this GPS navigation as an activated map, right? And there are lots of advantages of using the navigation app compared to the paper map. The GPS gives you instructions. It tells you turn left, go straight, after 50 meters, turn right, right? These instructions are based on your current location. So, for example, if you make a wrong turn, it automatically recalculates the route and gives you new instructions, right? You don't have to do anything for it. It does it on its own for you. It actually even factors in additional information compared to paper map. It factors in, for example, current traffic. And it uses it to choose the best route at that particular time, at the current time. And that's actually exactly what we need to do with our metadata. Not just make the metadata itself available to our engineers so that they can use it as a paper map to navigate. Instead, we need to activate the metadata so that the metadata itself actively helps our engineers and scientists by giving suggestions, hints, alerts, similar as the GPS navigation does it while driving. So to sum up, the active metadata is metadata available in the form that it allows to be used in data-related processes to actually drive these processes, to provide hints, alerts, suggestions, or even maybe make decisions if we have enough information and we trust it. And this is a huge change compared to how we understood the role of metadata up to now. Up to now, we were thinking of metadata mostly as a catalog, as a paper map that we give to someone and that they can use it. But now we want to change it. We want the metadata to be the driver of the processes. And for the actual deployment in your existing processes, it means to really revise and digitalize the processes that you currently have. And keep in mind that in some cases you can just improve the processes, but in many cases it may be quite a fundamental change, right? If I go back to the paper map example, we can improve the paper map as much as you want, but it's still going to be a paper map. GPS navigation is something completely different. And that's what digitalization and digital transformation is really about, right? We are digitalizing processes, we are reviewing them, revising them so that they are based on data. And so let's go through a more practical example of how metadata activation may look like for a data quality process. I picked one particular one because it's easy to follow, but you can relate it to any other processes, data privacy, data ops, and so on. But let's take a look at the data quality one. So, long time I had an issue with my bank sending me a new credit card to the address that I used when I opened my account. A few months after I opened the account, I actually moved and changed the mailing address. I moved just to the next city, so it was not even a different country, just the next city. But after about 2 years, when my card expired, I got a new one, and it was mailed to the old address, to the one that I used when I opened the account. And so I fixed it in the internet banking app, and a few years later, it again arrived to the to the wrong address. So that's definitely a data quality issue. And now, if you think about it, when it's actually investigated in the bank, what kind of metadata does the person who investigates it, the data quality steward, what kind of information do they need to actually investigate? What do they need to find out to really make a decision why that mailing address has not been fixed properly, why the change that I made has not been propagated? Well, first of all, they need to understand what are the sources for the mailing address. So it may be the original contract that I signed when I opened the account, and it should be actually also the internet banking application that I used to change my mailing address, right? So there may be multiple sources. If there are multiple sources, there must be some point where there's some decision logic that actually says which of these two sources is being used. Is it the newer one? Is it the one that we trust more? What is the logic for it? We need to understand that, right? There also may be some sort of filtering or anything like that applied along the way. So that's additional piece of information that we need to understand. Well, there also may have been some outages or breakages during the data synchronization. So we need to understand any sort of details about that, what kind of outages there were along the way, whether they were fixed or not, and so on. So that's, again, additional piece of information that we need to understand why the mailing address has not been propagated through. There may have also been already some data quality metrics somewhere along the way, along this data pipeline, that should have warned us about the data quality issue. Maybe it did, maybe it didn't. Maybe we need to review that data quality metric and have it updated, potentially, right? So if there's any data quality metric along the way, we should be aware of it as well. And last but not least, the data quality steward also needs to understand who else is consuming this data? Who else is using it to make decisions? Are those processes that are using the data maybe even more important than mailing the credit card to the wrong address, right? So all of these details need to be understood before we can actually start fixing that data quality issue. So this is all the metadata that person needs. And this would be the traditional passive metadata that people may spend days or weeks collecting and getting to understand so that they can start fixing. But what does it mean in this case to actually activate that metadata, provided that we already have it? Well, first of all, if you actually think about the process that I described, it's very well defined. It's quite fairly easy to actually automate it, right? Provided that you have the data lineage information about your data pipelines, where the data is coming from and where is it going to, you can actually automatically collect the information about the sources. You can automatically collect the information about how the data is translated, augmented, cleansed along the way. And you can identify these points very, very precisely. You can also collect the linked metadata information, such as operational metadata or data quality scores, from the processes that are responsible for particular data movements, right? And it is also possible to automatically notify the other users of this information, of these data records, that they are potentially using incorrect or improper data, right? So all of this can be actually collected in an automated fashion and presented to the data quality steward. And not only that, but we can actually very nicely highlight these points in red to the data quality steward and basically tell the DQ steward, there was an outage on March 1st, maybe you should look into that first, right? Because that may be the reason why the data quality issue arose. There's a logic that actually selects the mailing address from the two sources. That may be also something that you should look into, whether that logic is correct, whether it explains why the mailing address was not updated properly. So all of this is actually activating the metadata. And instead of this whole process taking days or weeks, with the active metadata, you get the information, including the suggestions, in the matter of minutes. Right? So that significantly reduces the time needed for the analysis. And the same you can apply to other processes. So now let's move on to how to actually do it. Obviously, that's something that will not happen on its own, right? It's something that you need to redesign the process and base it on the metadata, but also you need to have the metadata in the form that is actually usable for automation. Right? So in fact, what you need is some sort of platform, and it can be, for example, Manta as one of these platforms that actually collects the metadata and discovers the metadata from your environment. So it can be information from your data storage tools. It can be information from your data pipelines, from your ETL, Spark, PySpark, all of these tools that you use to move data from one place to another. And as a result, it actually provides the metadata and the lineage information for querying so that you can embed it into your processes. So it provides API to be able to query it, but also it provides analytics on top of that metadata, such as rule engine or machine learning, that will actually create notifications and hints about what have gone wrong and where to look for interesting points in that data pipeline for the specific process. So in the data quality case, it would be, for example, that point where the data was transformed and the right address was selected. Right? And all of this, you need some sort of platform to actually help you automate the processes that you're redesigning. All right, so to summarize, the active metadata is really where the data management space is headed to. And it's a key approach to keep and regain the flexibility that is required for innovation. To really, as a small company, to remain flexible and fast in being able to make changes. And as a large organization, to actually be able to make changes much faster compared to the current approach with manual processes and with manual investigation of issues or changes that need to be made. And that's it from me. So time for questions.